Hello everyone, my name is Paul and welcome to the DocIT channel. Today I think gonna be the most important lesson about Kafka. I'll answer such questions as what is topic, what is partition, what is offset. We're gonna talk about replication, retention period, and in-sync replicas. So what is topic? Topic in Kafka is heart of everything. Topic is stream of data in Kafka. We can create as much topics as we want in Apache Kafka, and it is identified only by unique name. You can imagine topic, it's like a name in the database table, where you can put all data. So let's talk about partitions. Topics are divided into a number of partitions, which contains message in an unchangeable sequence. Partitions allows us to split the data of a topic across multiple brokers, balance the load between brokers. Each partition can be consumed by only one consumer group, so the parallelism of your service is bound by the number of partitions in the topic has. Each record in the partition is assigned and identified by its unique offset. Offset is incremental by unique ID and holding ordered. You have remembered that all records is an unchangeable sequence, so it's not mutable. You cannot delete any record from the topic, you can only add new records there. So here's an example how to write into the topic. For example, we have three partitions. Partition number starts from 0, so we have partition 0, partition 1, and partition 2. And we've got 8 offsets in the partition 2. And we write a new message. Our message goes to the partition 2 and writes a new offset number 10. Then the new record goes to the partition 1, and as you can see, the new offset just appeared there, the number 8. And it's gonna be the same with the partition 0, the new offset with the number 11. All offsets in the partitions are ordered. Offsets is specific to partition. Offset 0 of partition 0 is completely different from offset 0 from partition 1. Number of partition is important when we create the topic, and that need to be specified at the time of created topic by CLI command. Data is stored in partition for a limited time, and it is immutable, and it can be changed. So how the record choose the partition where to save this? As you can know, the record consists from the key and the value. The key is not the partition number, but Kafka uses the key to specify the target partition. The default strategy is to choose a partition based on a hash of a key, or use a round-robin algorithm if the key is null. The number of partitions you can choose when you create a topic. So here's an example of the command in the terminal. While we're creating a new topic, we choose a zookeeper, replication factor, I will talk about this later, and partitions, and of course the topic unique name. If you understand that you need to update the number of partitions, of course you can do it manually by another one comment. By the way, I prepared a list of the good books about Kafka, and you can find this list just below this video. Now let's talk about topic replication. Apache Kafka is a distributed system. Replication is important for distributed system. Topic replication factor indicates how many copy we need to maintain the broker for the topic. One of the required parameter we need to specify at the time of the topic creation CLI command. And this command I already showed you on the previous slide. The default replication factor for the new topics is 1. So here's a replication example. Broker A is a leader, broker B and broker C are the followers. All new messages and the system start to replicate partitions from the broker A to the broker B and C, as you can see on the picture. And it is the same gonna be with the partition 1 and the partition 2. So what is retention period? A message sent to a Kafka cluster is appended to the end of one of the logs. The message remains in the topic for a configurable period of time or until a configurable size is reached, until the specified retention for the topic is exceeded. The message stays in the log even if the message has been consumed. If the log retention is set to 4 days, then the published message is available for consumption 4 days after it is published. After that, the message will be discarded to free up space. The performance of Kafka is not affected by the data size of messages, so retaining lots of data is not a problem. There are 2 retention parameters. First, it is log retention hours. Define the time a message is stored on a topic before it discards all log segments to the free up space. The default value is 168 hours. Another parameter is a log retention bytes. It's a size-based retention policy for logs. In other words, it is a loaded size of the topic. Now let's talk about in-sync replicas. In 2 words, it is a synchronization between followers workers with the leader. The definition of in-sync replicas depends on the topic configuration, but by default it means that a replica is or has been fully caught up with the leader in the last 10 seconds. At a minimum, the ICR will consist the leader replica and any additional follower replicas that are also considered in sync. Followers replicate data from the leader to themselves by sending fetch requests periodically, by default every 500 milliseconds. If a follower fails, then it will cease sending fetch request and after the default 10 seconds will be removed from the ICR. The ICR acts as a trade-off between safety and latency. As a producer, if we really didn't want to lose a message, we'd make sure that the message has been replicated to all replicas before receiving an acknowledgement. But this is problematic, as the loss or slowdown of the single replica could cause a partition to become unavailable or at extremely high latency. So the goal to be able to tolerate one of the more replicas being lost or being very slow. The video about acknowledgement you can find just in the linked video. When the producer uses the all value for the acknowledgement setting, it is saying on the give me an acknowledgement once all in-sync replicas have the message. If a replica has failed or is being really slow, it will not be a part of the ICR and will not cause unavailability and high latency. The minimum number of in-sync replicas specified how many replicas there are needed to be available for the producer to successfully send records to a partition. The number of replicas in your topic is specified by you when creating the topic. The number of replicas created can be changed in the future. The minimum number of in-sync replicas has nothing to do with the through output. Setting the minimum number of in-sync replicas to larger than 1 may ensure less or no data loss, but through output varies depending on the acknowledgement value configuration. Now let's talk why some replicas can be out of sync. The first reason it is slow replica. A follower replica that is consistently not able to be catch up with the writers on the leader for a certain period of time. One of the most common reasons for this is input-output bottleneck on the follower replica, causing it to append the copies messages at a rate slower than it can consume from the leader. Stock replica. A follower replica that has stopped fetching from the leader for a certain period of time. A replica could be stuck as due a garbage collector pause or because it has failed or died. Bootstrap replica. When the user increases the replication factor on the topic, the new follow replicas are out of sync until they are fully caught up with the leader's log. Now it's gonna be example if the one of the brokers go down. In this case, our leader broker goes down. All brokers are in sync. So the leader broker goes down. The follower broker takes responsibility of the leader and became the leader. And all new messages goes through this broker. When the ex-leader broker arrived, he took responsibility from the new leader and became the leader again. So guys, thank you for watching till the end. I hope you like this video. So please like and subscribe to this channel. For you just for a few seconds, but for me it's a good motivation to continue such videos like this.